Right, in this video for Chapter 9, Section 3, for Adept, we're going to see what happens when we attempt to solve a system of equations where some of the coefficients are written as a decimal as opposed to a fraction. So in the first example, it says multiply each equation by its lowest common denominator and then solve by elimination. So I'm going to solve this first using the method that you're already familiar with. So I've actually already written the multiplication both sides, so I'm going to multiply the left and the right side by 2, and this one both sides by 4, and we'll see what happens. Alright, so this is going to give me x minus 2y equals 0, because of course anything times 0 is just 0, and this is going to give me x plus 12y equals 28. And I think it's pretty obvious the easiest variable to eliminate would be x, and that is easily done just by multiplying both sides by -1, because all that's going to do is reverse the signs. So here's equation 1. I'll write it one more time. Why not? And here's equation 2 with all the signs reversed. So that becomes -12y, and that's -28. So now we can add everything together. And I'm going to get, of course, 0 over here. -2 take away 12, so I have -14y. And 0 minus 28, well, that's just -28. So I actually get a nice answer. So dividing both sides by -14, I finish off with y is equal to 2. But we need to solve for x, so let's do that right now. I will do this one in red. I'm going to use this one over here, x minus 2y equals 0. So x minus 2y, and I'll just replace y with 2. That is equal to 0. Well, that just means x take away 4 is 0, or another way of saying that is x is equal to 4. Right? So that is the solution to our system. This should be review anyway. Okay, we want to work with this same system of equations again, but it asks us to convert all fractions to decimals and then just solve using the substitution method. So 1/2 can be written as 0.5x, and we've got minus y is equal to 0. And 1/4 x, I would expect you to know that as 0.25x plus 3y, and that is equal to 7. So to use the substitution method, we just identify which of these variables is the easiest to isolate. And I think it's obvious, it's this y right up here. But it's negative. So that means 0.5x is equal to positive y, if I express it on the right. So that is the substitution that I'm going to use. So in equation 2, I have 0.25x plus 3y. But instead of writing y, I just write 0.5x from the substitution. And that, of course, is still equal to 7. So we can solve now. And 3 times 0.5x, that just gives me positive 1.5x, and that's equal to 7. And we have like terms, so I can add them together, which gives me 1.75x is equal to 7. And I will divide both sides by 1.75. Okay, and 1.75 is 1 3/4, or just 7/4. So when you divide, 7's actually cancel, and you just get 4. Okay, if you had a calculator, of course, you'd get that as well. So x is equal to 4, which we already knew from before, of course. Finally, to solve for y, that's really, really simple. I can just go back to this one. Y is equal to 0.5 times whatever x is, and we know that it's 4. So half of 4, of course, is 2. So y is equal to 2. Okay. So it is possible to work with decimals. As you can see, we get the same result. Now before you go jumping for joy thinking, oh my goodness, decimals are so great, they're easy, and I'm going to use them all the time to solve my problems. Well, think twice. Because I have a system here, and it asks us to convert all the fractions to decimals, as we did before. But it asks, do we see a problem? Well, I can see it already, but let's just write them out. So as a decimal, I get 0.5x plus 6y equals -11, which on the face of it doesn't seem like any trouble. But, ooh, 1 over 7? Well, if you want to work with that as a decimal, I think you're crazy. This is 0.1428557, and all 6 of those digits repeat over and over and over again. Here's x. 1/3. That's not bad to write, but it actually does go on forever. It's 0.3 repeating, and I have a y equal to 1. Okay, so I've just rewritten my system in decimal form, but I'm pretty sure you don't want to work with it. I don't. All right. Well, you might be wondering, how can you tell if a decimal is going to be nice to work with or not so nice? So below I have a list of some simple fractions, denominators 2 through 10, and we're going to look at their decimal forms and just, well, make the decision. Are they nice or not so nice? So it says circle all fractions whose denominators produce 3 or more decimal places. So 1/2 is just 0.5. Yeah, that's no problem. 1/3 is 0.3 repeating. That's definitely more than 3 because that goes on forever. 1/4 is 0.25. Not bad. 1/5 is 0.2. 1/6, that's 0.16 repeating. Well, that's not good. 1/7. Now that was the crazy one we saw before. That's 0.142857, and all of that repeats. That one's nuts. This one is not too bad. It's 0.125, but it does have 3 or more decimals. In this case, 3 exactly. 1 divided by 9, or 1/9, that is 0.1 repeating, so that's not good. And 1/10, well, that's just 0.1. Right? So out of these 9 fractions, only 3 or 4 of them were actually, well, not bad to work with. So don't think decimals are always going to be there for you to solve your problems, because very often they create more problems than they solve.